It's Friday, the 4th of November, and I'm happy to report today a near textbook example of handling an emergency return in Buenos Aires, Argentina on 27 October by an American Airlines 777-200. My name's Juan Brown. You're watching the Blanco Lirio channel, and I'm a first officer on the Boeing 777. Let's get into what happened here and clear up some common misconceptions that people still have about dealing with these sorts of emergencies. Let's start first with Simon Radecki's Aviation Herald. An American Airlines Boeing 777-200 registration November 765 Alpha November performing flight as American Airlines Flight 908 from Buenos Aires, Argentina to Miami was climbing out of Buenos Aires runway 11 when at about 2,000 feet the crew received a left-hand engine. That's the Trent 892 engines. Remember, on the American Airlines fleet of 200s, they use the three-stage Trent engines as opposed to United Airlines and many other airlines that use the Pratt & Whitney engines. Remember, it was the Pratt & Whitney 777 engines at United that were subject to the big airworthiness directive regarding fan blade failures. This is the Trent, the Rolls-Royce, a different engine. At 2,000 feet, the crew received a left-hand engine Trent 892 stall indication, prompting the crew to stop the climb at 3,000 feet and return to Buenos Aires. Well, let's see what the rest of this says. The aircraft landed safely back on runway 11 about 20 minutes after departure, and they're opening up an investigation. On November 1st, 2022, the Aviation Herald received information that the left-hand fuel flow indication blanked out when the aircraft accelerated through 120 knots indicated airspeed. That would be right there on the takeoff roll. During climb out, after the landing gear had been retracted, the left-hand EPR blanked out, and a cabin crew alerted the flight crew to sparks and noise coming from the left-hand engine, prompting the flight crew to return to the airport. And here's some pictures of the engine after they landed. And it looks like quite a bit of the honeycomb structure here has been destroyed, and some of the bits of honeycomb are still sitting underneath the engine here. It looks like these turbine blades are all intact from this picture, but it's a limited view. Now let's look at the ground track here on FlightAware, and this is why I call this a textbook example. This looks like exactly the way we practice it in the simulator. Boom, you get the emergency either on takeoff or on departure, and you turn right around and do an emergency return to the airport, get set up on a downwind, and get lined up for the instrument approach right back in and land. In the meantime, getting all of your checklists done in a short amount of time. These guys were back on the ground in about 13 or 14 minutes. Not only is the crew regularly trained for this sort of an emergency, but it's pre-briefed in the departure briefing. What is going to be the plan on this departure if in the event that we have an emergency? So they've already got that briefed up and set up and ready to deploy, as well as the landing distances. Part of the job of the FO or FB is to determine the landing distances required with the current weight of the aircraft after having lost one engine. So all that's already predetermined. They've already determined that they can safely get back to this airport and land in the runway that's available at their current weight on one engine. And all that is done prior to the departure, planning on this sort of an event happening. So if the crew first became aware of this engine problem right around 2,000 feet, it's good to see that they reacted quickly and came up with plan B and began to get this aircraft turning around and heading back towards the landing runway in a short amount of time. In other words, they didn't waste a lot of time climbing out on the standard instrument departure or climbing out straight ahead, sorting out the problem. They immediately got to jumping on the problem and getting the aircraft turned around and headed back to the airport that they took off from. So the crew figures they've got a problem right about here at 2,000 feet. The first thing that we're trained to do is somebody say, my aircraft, and take over the hand flying or the autopilot flying of the aircraft, and then direct somebody else to begin the checklists. Typically in training, we found that if the first officer takes over the flying of the aircraft, this allows the captain to get into the checklists and do a better job of managing the entire emergency procedure with everybody involved between the crew in the back of the aircraft, and ATC, though the first officer flying the aircraft also can fly the aircraft and run the radios. So my aircraft checklist. Now, what checklist do you want, Captain? In this case, we've got a number of conflicting reports coming at us. Now, the initial report said engine stall. Well, an engine stall is something like a compressor stall. That's a chugging of the engine, a bam, 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 usually followed by explosions coming out of the back of the engine. Typically, that follows something like a bird strike. Engine surge or stall. In that case, you would just retard the throttle until the surging stops, or the compressor stalling stops, and then continue at that power setting. The other side of this report indicated that, well, first it indicated that a couple of different engine indications began blanking out, and it wasn't until the crew from the back of the aircraft notified him of sparks flying out of the back of the engine that there was really a problem with the engine. So I suspect what's happening here is something is catching on fire on that engine, and that is burning through a lot of these indication systems. And so instead of the engine indicating, the ICAS system giving you a warning about what's going on with the engine, those wires are getting burned through, and you're not getting the warning from the ICAS, or engine indication and crew alerting system. Instead, you're being told of the condition of the engine by the folks in the back of the airplane. So again, what checklist do you want to run? There are a number of different checklists you can choose from. The first is a quick reaction card located right next to your right hand knee in the FO side, and you can pull that up, and that's got a couple of quick reaction emergency checklists on it. That's broken down into two categories: unenunciated or enunciated. Well, if you had an engine fire that burned through some of the wiring for the indication system, and it's the crew in back that's telling you about this emergency, you're basically running a unenunciated engine fire checklist. Well, there is no such thing as an unenunciated engine fire checklist, but there is unenunciated engine severe damage or separation checklist. They both lead you down the same basic path. You need to get the engine shut down and secured. In order to secure an engine on the 777 according to the checklist, well, first off, we have the pilot flying and the pilot monitoring. So the pilot monitoring runs the checklist, and the first step is to turn off the affected auto throttle switch here. Pilot monitoring does that with confirmation with the pilot flying. Then the pilot flying, with the confirmation of the pilot monitoring, retards the affected throttle to idle. This helps you verify that and identify that you are shutting down the correct engine. Then the pilot monitoring, with confirmation by the pilot flying, shuts down the fuel control switch, or shuts off the fuel control switch, which in turn shuts down the engine. Then, if you have an engine fire indication, the pilot monitoring, with confirmation of the pilot flying, pulls the correct engine fire handle located down here. All of the checklists, the emergency checklists, will automatically pop up right here on the ICAS, or engine alerting or engine indication and crew alerting system. Once you've got through those first steps, then you can just follow through with the rest of the checklists, which will be located right there. If in the event the engine is surging or compressor stalling, you would simply get the dog out of the way and do the first two steps of the procedure. Auto throttle arm switch affected side off, and then retard the affected throttle until the surging stops, and then go to the checklist. Now let's talk a little bit about performance on these aircraft. At over 91,000 pounds of thrust from the Trent engines on the 777-200 apiece, there is an excess amount of performance on these aircraft. So each departure is engineered to derate or use less power than is required, less power than full power for the departure that will keep you clear of all obstacles on one engine. In other words, each departure is engineered to be flown on one engine and have adequate climb rate to keep you clear of all the obstacles on the standard instrument departure procedure at that reduced power setting on one engine. Now, once you lose that engine, you can always select additional power on the remaining good engine should you need it. For example, the flight out of Miami, well, on the 200, it's got a maximum gross weight of 650,000 pounds. A typical flight out of Miami, by the time you add up all the fuel, passengers, baggage, and cargo, that's about 150,000 pounds of fuel to get from Buenos Aires back to Miami plus reserves. The total weight of the aircraft is going to weigh in about 540 to 550,000 pounds, so about 100,000 pounds less than the maximum gross weight of the aircraft. So, with that excess performance, what engineers will do is we will derate the engines to match the performance required for this departure. Why do we bother derating the engines on takeoff? Because remember, the airline does not own these engines, they lease the engines. And so you need to extend the lease life of the engine when it's acceptable to do so, and extend the life and the wear and reduce the wear and tear on the engine. Now, there are certain requirements where you cannot derate the engine, where you have to use maximum power, but generally, under optimum conditions, you use a derated power takeoff. And again, once you have an emergency, you can always increase the power as required up to the maximum power of the engine, maximum continuous power. Now, what about the limitation of maximum landing weight? The question often comes up, how come the crew doesn't dump fuel to reduce the weight of the aircraft prior to landing? The maximum landing weight on the 777-200 is 460,000 pounds. This aircraft is operating right in this configuration here about 540 pounds or so, so nearly 100,000 pounds over its maximum landing weight. Remember, the maximum landing weight is not a hard limitation. In the event of an emergency, you can always land the aircraft over its maximum landing weight. All that max landing weight means, or landing the aircraft over its max landing weight, means that there is going to be a required inspection of the aircraft to be done after landing. And it's a short 30 or 45 minute inspection that will have to be performed by the maintenance personnel once the aircraft lands. There's techniques to landing overweight, and that's just to try and do a gentle landing. Don't smash it in over your maximum landing weight, or that inspection could require some maintenance on the aircraft. And remember, too, the crew has already, before they even took off, they've already measured the actual runway length and compared it to their actual landing distance on one engine, and have determined that based on the conditions of the runway, whether it be dry, wet, or what have you, and the current weight of the aircraft, that they can make their landing distance. So they don't need to dump fuel in an effort to make the landing distance for the landing runway. Besides, you don't want to be messing around with dumping fuel. If you've got an engine fire, you just want to get back on the ground as soon as possible. So you don't need to mess with dumping fuel. It's okay to land overweight. As far as landing on one engine at this higher weight, you're going to be using a flaps 20 landing setting as opposed to flaps 25 or flaps 30. So you're going to use less flaps so that in the event of a go-around, you've got enough excess energy to safely go around on one engine. If in the event of a go-around, you will be selecting flaps 5 as opposed to flaps 20 to give you the performance that you need for a single engine go-around. You'll also be pre-briefing the crew and ATC that if in the event of a single engine go-around, you're going to simply continue on straight ahead and climb out to 1,000 feet, terrain permitting, on your single engine go-around. So you got all of that pre-briefed ahead of time. Meanwhile, right here at about 1,500 feet, you see this crew is stabilized on approach, on glide slope, and on speed. It's going to be a considerably higher speed at this weight. Here they are at about 219 miles per hour ground speed for this heavier weight single engine landing. The runway length for runway 11 here at EZE is over 10,000 feet long. Your landing distance on one engine at this weight on a dry runway is going to be about 5,000 feet, so only about half that runway length. If the runway's wet, that landing distance on one engine will go up to nearly 6,500 or close to 7,000 feet. So plenty of room to get this aircraft stopped. Once you get the aircraft stopped on the runway, we typically have the ARFF crews check the aircraft out for any damage, make sure that that fires out. As soon as you get that aircraft stopped, the captain needs to get on that PA and say something to reassure the passengers, remain seated, remain seated, remain seated, to avoid the possibility of having an uncommanded evacuation on the aircraft after one of these emergency events. Then usually once you've been cleared off by ARFF, you can taxi back to parking on the remaining one good engine. So again, great job to the crew of American Airlines Flight 908. Looks like a textbook example of how to handle this emergency. And again, remember, these aircraft are designed to fly on one engine all the way from takeoff back around to landing. And also, the other point is an overweight landing is no big deal. You don't need to necessarily dump fuel to make your landing weight less than your overweight landing limit. Thanks so much for your support of this channel, especially the folks over on Patreon that make this content possible. See you here.